Okay, hello everybody. Welcome to the second day of the developer conference. I would like to just to give you short information about lightning talks before the first session begins. There are lightning talks scheduled 5:30 today. I think 5:30. And so everybody is encouraged to propose some topic. Upstairs there is a whiteboard, then you can put your topic there, and the best topics, the most interesting ones, will be chosen 5:30, and you can take part of the lightning talks session. Okay, so the first session is performance testing. So over to you.
So good morning again. We are really glad that you managed to wake up so early and made it to here, even though there was the party yesterday. Unfortunately, we weren't there because we were still preparing the presentation. So, Pavel, teda. No. Okay, so first let's try some exercise at the beginning to wake up even more. So first, what is your favorite programming language? Hands up for Ruby. No Ruby's, okay. That's a pity, you will see soon. What about Python? Hands up. Okay, nice. Java? Good. And how about JavaScript, Node.js, and techniques like that? Cool. I'm sorry to disappoint the others. So the thing is that we developed a very simple service that just listens at some TCP socket and receives a string, reverses it, and sends it back. And we have developed this service in these 4 different languages. So this is the Ruby implementation. What's that, Python? Python 1. This is JavaScript. This will be executed using Node.js. And here we have Java. Good morning, guys. And we should have started slightly later, I guess. Good morning, take a seat. It's still nice that you made it to the presentation. Okay, so who of you who has your favorite programming language represented here thinks that the implementation of this service will be the fastest? Hands up. Okay, once again, we have 4 implementations of the same service in 4 different languages. Do you think that your favorite language will be the fastest here, the most performant one? Okay. And what was your favorite? Java, okay. So, let's give it a try. First, my name is Martin Večeřa, this is Pavel Macík. We are the developers of a performance testing framework called PerfCake. Tak asi další slide. So, have you ever heard of PerfCake? Have you ever seen any presentation? Hands up again. You can switch your hands during the exercise. Okay, so PerfCake is a quite lightweight performance testing tool. Our aim is to create simply the best solution. It's that simple. We would like to be most user-friendly, be able to generate the highest load, and have the most cool features among all performance tools. So let's get back to our demo. We would like to show you the tool today using some real examples. You won't be talking much about theory and see it using some real deeds. So first, the question I started with, we can easily measure the performance of those 4 services using PerfCake. And Pavel will now develop the scenario for that. Because PerfCake is driven using scenarios, and it's quite simple to specify it. First, we will specify that the test will run for 20 seconds using 20 threads, or 25, it does not matter much. We need to okay. We need to specify how the messages will be generated. So in our case, we are trying to send as much load to the service as possible. This default message generator tries to find the point where the service is saturated and cannot handle more load. Now the sender, as I mentioned, the service is implemented using plain sockets. So there's the plain socket sender. We need to specify target address, which is some property that can be provided from command line when running PerfCake, and it has some default value. Actually, there are 2 properties. One is the server host and the other is the server port. All the services will be listening at the same port. Of course, we won't run them at the same time. We will run first, stop it, and the second one, and so on. So the goal here is to develop just a single scenario for all of these services. By this, we want to show the flexibility of PerfCake, that it's possible to measure application written in any language. It just depends on the communication interface. So, some reporting. We would like to measure throughput of the application or the service. We would like to see the throughput at console, let's say every single second, and then we would like to see some chart of the results, like, or we would like to measure the value or values every 500 milliseconds. The chart needs to specify some attributes, some y-axis, name of the chart. Again, we use the property here. This allows us to create different charts with different names, and this is the only thing that will be changed for every programming language. But we are able to provide it from command line, as we will see soon. And could you please put the question down, and we can discuss that in the end. Okay. Thank you. And the message that will be sent is just stored in a file. It's something, some simple string. Okay, that's the specification of the scenario, and now we can run the service and run the first test. Do you have the service already running? Okay, let's start with, for example, Ruby. Is it visible? Asi zvětš ten fond. No. So let's start with the Ruby service. And Pavel has specified the language property that will be placed in the scenario. And now the test runs. Before we will show you the actual results, in the end, I would like to stress that the implementations of this service are far from being optimal. So do not start fighting immediately. And we are really open to have implementations in any other languages and accept pull requests that would improve their current implementation. all the services, all the demos you will see today are publicly available on GitHub. We will show you the link in the end. And you are welcome to become part of our community and contribute whatever you want, even those services or anything else. So, where we are. As you can see, this is the, we are already using the Python implementation. As you can see at the input, we can, or we have some information about the throughput, performance, and so on. So now let's give a try to JavaScript implementation using Node.js. And okay, do you remember the numbers, by the way? Which one is the fastest right now? For JavaScript, doing quite well. And the last implementation is in Java. Java is, okay, we compiled it before, so we don't need to compile the source code again. And so. At the beginning of each performance test, PerfCake is able to benchmark the current machine to find out the resolution of system timer and tell you what is the highest throughput that you can measure on this current machine, because we already hit a situation where the actual service was faster than we were able to measure. But we are using, PerfCake is implemented in Java, to be honest with you. And we use some system nanoseconds timer. So usually we are around or we are able to differentiate, or the system is able to differentiate time in the amount of I don't know, several hundreds of nanoseconds. We are not able to get anything more precise. So we have the results. I guess you don't remember the numbers. So to show you the winner, we have some cool new feature in PerfCake, and that's the generation of charts. So let's have a look. On the charts from the current measurement, we can see the service in one of the languages. As you can see, the property from the command line made it to here, so echo in Java. Some minimum, maximum values, the current result measured at this very moment, and some average. But what is more interesting is the comparison of these values. So let's scroll down to the average directly. So here we are. As you can see, the Ruby implementation was the best one. And the Java. And it's not likely to be influenced by anything in the system, because we always get a very similar line for all these languages. So maybe you should consider switching your favorite language. But as I mentioned, the services are far from being optimal. So this is where we would like to welcome any pull requests in GitHub to be able to improve that further. So let's try something completely different. We would like to show you cool features regarding memory leak detection. Because PerfCake is able to communicate with the application being tested and record it's memory usage. And maybe you could just copy the scenario and not writing it right now to save some time. Okay. Originally, we wanted to show you or to develop the scenario in here, but actually we realized we are slightly shorter on time than we thought, so we will just copy it here and I'll describe it. Again, it's a simple scenario, and we have a service that is implemented in Java using Vert.x. It has some memory leak incorporated. We put it in there so we know it is there. And we would like to show you how you can find out this with PerfCake. So first, the scenario. It's specified that it will run for 3 minutes using 25 threads. Again, the same way of generating the messages. The service listens at the HTTP port. We will be using put method here. And again, we'll be reporting to console and to chart. But the new thing here is the memory usage reporter. This is the piece of the puzzle that monitors the memory in the application under stress. And we have memory detection switched on. We use linear regression analysis of the memory usage over time to find out whether there is a probability of having a memory leak in the application. So, yeah, and one more feature. This mainly affects the Java world because I suppose you know what garbage collection is. So there is a new option in PerfCake prepared for this release that will come in spring equinox. And that's the ability to call garbage collection before reporting back the memory status. This sort of softens the development of memory usage over time. We do not have some saw shape in the chart, but a straight line. We will show that later. And yeah, thank you. One more thing is that when PerfCake detects the memory leak, it automatically dumps out or you can configure it to automatically dump out the current state of Heap. So you can open it in some profiler and find out what's going on. So let's give it a try. And one more thing, in this scenario, we used validation. We are able to validate the responses to the original message, because sometimes your service can start acting really fast, but the response is not the actual response to your request, but it can be just some error message like, hey, I'm busy, come back later, or something like that. So we need to validate the responses to make sure that we still receive something we asked for. This is the line with validator. We use regular expression and trying to find out that the message was properly consumed. You can run the scenarios meanwhile, I guess.
I think one thing, we would run the scenario twice.
I will mention it. The scenario will be executed twice. First, we will be using the garbage collection before reporting the memory status, and second, we won't use that. So you will be able to see the difference in or how the memory usage develops over time. And one more thing, it's about architecture of PerfCake. We are aiming at having this sort of component architecture for us to be able to switch each component for a different implementation easily. All of the components have some defined interface, so we are able to switch the senders. This is the stuff that actually communicates with the service or application you are measuring. That means that it has the protocol-specific stuff in it. The validation, we have regular expression validator, we have some rules validator implemented. What we have more? Script validator, we are able to run some scripts so you can develop anything in your favorite language, again, to validate the message. For reporting, we have that throughput reporter that measures the current application throughput among all the threads. Second, we have response time reporter that just measures the response time of each single request. Plus the so-called destinations. This is where the results are recorded. So you're able to see console destination and chart destination. This means that the results are printed in console and in the chart. Also, we heavily use CSV destination. This is just simple comma-separated values file because it's easy for processing later in almost any software. Almost anything can import it. For example, we can import such a file in LibreOffice and create a chart in there or further manipulate with those data. So it takes some while for PerfCake to make sure that the memory leak is actually there. You could see it on the last line. The memory leak used to be null, and now it's set to true. And in the upper window where the service is running, you can see that the heap dump was saved. I think you can stop it now and run the second one. This was with or without garbage collection? Yeah, this was the okay. So Pavel restarts the server for it to have, or for the second measurement to have the same conditions. And meanwhile, the second execution is running. We can inspect the heap dump file. So, as I mentioned, the heap dump was automatically saved upon the detection of memory leak. So in a situation where the slope of the memory usage overcame some given value, and it's as easy as opening the heap dump in JProfiler or YourKit profiler or anything like that. Let's inspect the biggest objects now, and we can see that it's actually in our service, in our code, that there is some strange usage of collections of a hash map. So let's see the classes, and the highest instance count in our code is for HTTP echo vertical bed key. So that's the memory leak we put in, and it's really visible in here. So if you ever had an application with memory leak, it's highly probable that you'll be able to first easily detect it using PerfCake, and second, find it in the heap dump. We can have a look at the source code of the bed key for you to see how that was implemented. As you can see, the class bed key at the beginning is just a key that is used in hash map, but it does not implement hash code and equals methods. And for each request, we are storing actually the address where the request came from and the body of the message. So in correct implementation, it will save us the last message that was sent from the given address. But as we use the bed key, the bed implementation with our hash code and equals, hash map then relies on the implementations from the object class. This means every single instance of bed key has a different hash code, and new record is put in the hash map. So that's it. Did the second run finish already? But we detected the memory leak, okay. So let's see the charts for that. we won't wait for it to finish now because it takes some time. And we have the charts already prepared from yesterday. So, and that's the result. Okay. Actually, the chart implementation we use in PerfCake is Google Charts. So the usage of this is slightly limited to the number of values you measure or record in the chart and the number of subsequent runs that you want to be combined in a single chart. Again, here you can see the chart that shows the memory usage from those two runs. The upper one in blue is where the garbage collection was switched off, or actually we did not ask for garbage collector to run before we sent back the amount of memory used, and you can see the saw shape. And the second one is with garbage collector, or we called garbage collector each time before we reported back the memory status. So you can see that the line is more smooth. And it's easier for us then to tell whether there is likely to be a memory leak, because now it's very obvious because the memory leak was quite obvious in there, and it was the only thing the application did. But in more complicated scenarios, the upper chart would be, more wild, and it won't be that easy to see that it has a tendency to grow up. So this is why we put in the option to switch on garbage collection. So that was it. Did I forget anything? Nice. And now again, the third demo we have prepared. Again, something completely different. And it's something more complex. There is another option to specify the scenarios. What you saw so far was sort of DSL language for PerfCake for scenario specification. This is implemented using Groovy. The code you saw and we used to implement, that's actually it. This is a Groovy code, but bent in a way that it allows us to use this type of syntax. And originally, the implementation we had in PerfCake was simply XML file because it's easy to process. And also the XML file is stored from IDE plugins we have for PerfCake. If you can show some, or do you have it prepared, or other than plugin? Okay, maybe we will try that in the end. Pavel doesn't have it open right now. But we actually have plugins for Eclipse and IntelliJ IDEA. And it can open just the XML file and store it back. We do not have support for the DSLs right now because we are not able to save them, just read them. Okay, we are going to give it a try. Are we lucky today? Okay. Yeah, that's it. That's the plugin in IntelliJ IDEA. It just shows the structure of the scenario, and you are able to pull the components from the panel in the left, edit properties, and whatever. It depends what you would prefer for specifying the scenario. I most prefer the DSL for now. It depends. So let's get back to the XML one. It's slightly more complicated, so it's that long. It's just because there are more properties. We have a test or a service that has a Java messaging service interface. So this is again to show that we are able to communicate with service or with different services having different interface. Actually, we will start Whitefly, which is a new version of JBoss application server, and the service is in there, and we can measure its performance. If you can show the scenario once again, or run it meanwhile. Okay. Here the aim of this exercise is to measure the scenario multiple times using different amount of threads to see where the service gets saturated and it cannot handle more. JMS has simple, more configuration parameters. If you scroll down, the reporting is basically the same: throughput, response time reporting, charts, and memory usage reporter. This is quite complex. You can have a look on that later in the on GitHub to just get the idea how a complex scenario can be created. And now for the charts, we are short on time, so we are not able to run it now. Are we there yet? Okay. Yeah. So the comparison of the number of threads, it's slightly. Okay. Oh, it's better than yesterday. That was memory. I meant the number of the performance, the throughput, compared. Here we go. So here you can see the performance of the service, and using the different amount or different number of threads. Single thread, the blue line, was not that fast. 5 threads was faster, 25 threads was even faster, and 125 threads was the slowest one, because we were behind the point where the server was able to handle that amount of threads. Again, the scenario was executed on laptop, so in reality we would be using probably 2 servers, one for generating the load, the other for running the service, and the number of threads would be quite different. I would expect something around like 400 or maybe even more for a real drop down to show. And yeah, that was that. So let's get back to slides. Just to summarize that and give space for your questions as well. Can we see it full? Oh, there it was. So the next one. So if you are serious about performance testing, and the hint here would be that this is the encouraged approach, I would recommend you reading the diploma thesis here. It's done by one of our colleagues. It compares current performance tools, including Apache JMeter, Faban, GetLink is there, and PerfCake, for you to be able to see how we stand with PerfCake in, let's say, objective way. So that's it. As I mentioned, we would like to see you become part of our community, because we really need more developers. Even for core features in PerfCake, this is still research and development. For example, last week we tried putting in some Goldman Sachs collections implementations to find out whether we can be even faster in generating the load on the services. Unfortunately, this did not show up to be quite true, so we relied on current implementation. So next slide, please. This is the link to the sources of these demos, you can find us easily at GitHub, or you can just simply open perfcake.org and you have all links there. This is QR code for the current slides. And we will definitely have these links on Twitter again. So now is some brief time for your questions. I will repeat the questions.
What's the relationship to SmartFrog? Is it a 100% replacement?
It does not have anything in common with SmartFrog. SmartFrog is not a tool for generating code. SmartFrog is a tool for running some services or something in cluster to control execution of processes in a clustered environment. You have to implement it there.
Okay. Is there an option for warm-up?
Yeah, sorry. I mentioned that I will repeat the question and I did not. So the question was whether PerfCake is a replacement of SmartFrog. This is just for record. Okay, next question, please.
Is there an option for warm-up?
Yeah, there is. The question is whether there is an option for warm-up. There is warm-up in PerfCake. We use it all time. Again, there is some smart way implemented in PerfCake that it automatically detects when the warm-up is over. Again, using some analysis of throughput. We did not switch it on because it's not that ready in those charts yet. So.
And you started here from console. I think it must be possible to start from Jenkins too, but the question is actually, is there some comfortable way to set up the whole class path for PerfCake?
Okay.
Because I am allowed to
that's
switch
clear.
components for my own implementation. So that's the question.
Yeah. The question is whether there is some more convenient way of running PerfCake or any other way than the command line. There are multiple ways. We have a Maven plugin. I think Vojta Juranek developed that. We have. You can also make PerfCake as a dependency in your project, so you can enable the scenario using API. You can run the scenario using API, and you can run it using Maven even in the source code. So just Maven exec, and that would be it. So.
There's actually a plugin for Maven to run it by Maven.
Yeah, I mentioned the plugin for Maven. You can see here. We have the documentation that currently is released even in HTML. So one more question. Yep.
I'd like to know what is about the automation of testing something. I mean, what you described was how to run a single measurement or something, like measuring one parameter or a small set of parameters, and you need to write some description like with TSL or XML, which is even longer.
Okay. The question is whether there is an automation of running multiple runs, right, or multiple different scenarios. This is not the aim of PerfCake. PerfCake just runs the scenario and that's it. We rely, when we actually use it, because we eat our own dog food, we actually run it from Jenkins, where we have some other script to control the execution and run multiple scenarios. So that's it. Okay. One last thing, just to summarize that, Pavel, if you can, the next slide. Is it on computers? We can measure its performance. That's the main message for this presentation. And second, I would like to thank you for coming here, because events like that is always the biggest motivation for us to put the most features in it and to concentrate on it and to fix bugs and so on. So thank you very much for your attention. Yeah, we have some 2 minutes, I guess, because you ended late. There is a contest now. If anybody of you want to win a nice T-shirt, The question is, what are the ways of specifying scenarios for PerfCake? You already have T-shirt. Anybody? Do you remember? Okay.
Writing a description in DSL.
XML, DSL.
IntelliJ IPR plugin.
Yeah, and IntelliJ. Okay, guys, you have it. What sizes?
M, I think.
M and? I only have one M. Okay. So that's it. Stop by here. And, okay, thank you.
Okay, thank you. Next session will start at 9:50.
Co? Jo. Here you are. Thank you.